So today we're going to be looking at radians, and let's introduce those as a new unit of measurement. And the first thing you might ask is, well, what is a radian? Well, you might be already familiar with the idea of what are degrees. Now, degrees are basically if we take, let's draw this visually. If we take a circle, and I cut that circle into pieces. How many pieces do you ask? Well, how about 360 pieces? Why 360? Well, just because. That's 4 pieces. Let's cut it into 8 pieces, and let's cut it all the way down into, you have this tiny little sliver right here. Then instead of being 360 degrees is equal to 1 degree. Now this is what we call a central measurement, meaning it's an internal form of measurement. I know that no matter how big or how small my circle is, that distance or that degree of rotation or that measurement of rotation is always going to be equal to 1 degree, no matter how long or how short these sides are. So if these are super long, that's 1 degree. If these are super short, that's still 1 degree. It's a central measure of rotation. A radian is that same thing. We're taking a measurement of rotation, but instead of looking at it from the inside, let's go ahead and circle this and say this is where degrees are. It's central. A radian is instead measuring the distance around a circle. So a radian says, hey, instead of measuring how far away from the other direction I'm going, how about I take this circle and I want to, let's say I'm standing right here and I want to figure out how far around the circle I've walked. Well, first off, I need to figure out the circumference of a circle. The circumference is 2 pi r. Okay, well, I need a radius. Well, how about let's give this radius of 1. Okay, so that means that the radius is 1. So 2 pi times 1, which is basically just 2 pi. So if I walk all the way around the circle, just taking a lovely little stroll all the way around the circle, I have walked a total of 2 pi distance. 2 pi distance. Now, what is this 2 pi distance? Well, we're going to call this, we've walked a total of 2 pi radians. Why a radian? Well, because it's based off of a radius of 1. You walked a total distance of 2 pi radians, which is why the radian, our unit of measure, a full circle has 2 pi of those. Now, what happens if our radius was instead a bigger circle? So let's draw ourselves a slightly bigger example. Or, yeah, let's draw ourselves a smaller example, just because I'm a little lazy right now and I don't want to draw a giant circle. So here's you, and you have a radius, let's say, of 0.1. Or let's do 0.5. Even though that's realistically not half, you can see that. We're going to say that's 0.5. And you walk your way around the circle, and you're like, do. That was much faster. Okay, well, the circumference is 2 pi r. So your circumference is 2 pi times 0.5. So your circumference is half of 2 is 1. You walked a total of pi. Now, that doesn't change your degree of measurement. How far around the circle did you go? You went 1 full circle. You went less distance, but you still went 1 full circle. How far around is 1 full circle? So you went 1 full circle, so you went 2 pi radians. We don't care that your distance was pi. We care that you went 1 full circle, which is based off of the unit circle, so you went 2 pi radians around. Side note, we do not care how far you went, it's how far around. So instead of being a central angle measure, so degrees, let's bring this all back around. So degrees is central measurement of rotation. So if degrees are central, then radians are an external measurement. They both measure the same thing. How far around something did you go? What is that degree, or what is that measurement of rotation as you open something up or move something around, in this case, in a circle? Well, degrees, we arbitrarily split it into 360. With radians, we look at the length around a standard circle, and then no matter how big or small that circle is, we find that length as well. So knowing that, the conversion between degrees and radians is going to be something like this. If you have degrees, whatever fraction of that circle you walked is going to be divided by 360. Is going to be equal to that same fraction of the circle divided by 2 pi. Because remember, the full circle, if you walk all the way around, is 2 pi radians. The full circle all the way around is 360. Now, you may see a shorter version of this, which would be x over 180 degrees is equal to y over pi radians. And most of the time, I'm actually going to use this, not because it's any different. It's the same relationship, but it's smaller numbers and easier to work with. But we have this right here because this is the conversion between what part of a circle did you walk is equal to the same part of a circle that you walked. This unit of measurement is a fraction of a circle, let's say half. So if you walk half of a circle, 180 degrees. If you walk half of a circle, it's pi radians. So half is still equal to half. Let's jump into a few examples. Okay, so for number 1, I have 30 degrees. Now I'm going to be using my shortened version. I'm not going to use the full conversion simply because those are going to be bigger numbers. And why use bigger numbers when I can use their smaller equivalents? So if I have 30 degrees, well, 30 degrees out of 360 is equal to some unknown value of my 2 pi. So I need to figure out what fraction of a circle that is, and I can convert that to that amount of radians. Well, 30 out of 360, let's take a look at this. That is 1/12 of a circle. I know I just said that I was going to be using this, and I realized I wrote down the 360, so whatever. So 1/12 of a circle. Well, what is 1/12 of 2 pi? So what I could do is I could say, well, what is 1/12 of 2 pi? So 2 pi times 1/12. This will give me, let's say, pi over 6. Or what we could do is we could cross multiply, or we could solve for y, whichever way you best find appropriate. Cross multiplication is the standard way to introduce this. But I like to say, okay, I'm looking for 1/12 of a circle. Let's multiply that full circle, 2 pi, times 1/12, which is going to give me a pi over 6. Let's double check our work by cross multiplying here. So that's going to give me a 12y is equal to 2 pi. And then I'm going to take y, and I'm going to say 2 pi divided by 12. Notice same relationships going on right here. And that's going to give me 8 pi over 6. So I have pi over 6 radians is the same thing as 30 degrees. Now if I had 90 degrees, I'm going to do the same thing. So 90 degrees over 360. What fraction is this circle? Well, that's 1/4 of a circle. Is equal to what fraction of a full circle using 2 pi? So I could cross multiply and get this, or I could say, okay, well, 2 pi, I'm taking 1/4 of that, which is 2/4 pi, which is half pi, or pi over 2. And I'm expecting to get that as my answer. Let's cross multiply. So I get 4y is 2 pi. If I divide both sides by 4, y is 2 pi divided by 4, or just pi over 2 radians. Again, I get the same value. So if it's 1/4 of a circle, I'm walking 1/4 of a circle, so 1/4 of 2 pi is pi over 2. So having seen those, what I want you to do is I want you to try out 45 and 135. Pause the video, unpause it when you're done, and see how well you did. Okay, so let's take a look at the same thing. Here I have 45 degrees, and I want to find what fraction of a full circle is 45 degrees. Let's see, well, if 90 was 1/4, half of 90 is half of a fourth. That's going to be an eighth of a circle. So I could say 2 pi times an eighth, which is 2 pi over 8, which is going to be pi over 4. I bet you I'm going to get pi over 4. So let's go ahead and solve this algebraically. Cross multiply. 8y equals 2 pi divided by 8. Y equals 2 pi divided by 8, which is pi over 4. Boom. Hopefully you did pretty good on that one. Same thing with 135. I want to figure out what fraction of 135 of a full circle would be measurements in radians. So 135 out of 360. Let's see, if 45 was an eighth of a circle, 45 times 3 is 135. So that's going to be 3/8 of a circle. So I could take 2 pi, which is the full circle, and multiply it times 3/8. Let's see, so that would be 6 over 8, which is going to be 3/4 pi is what I'm expecting to get. Let's solve this algebraically. 8y equals 6 pi. Y equals 6/8 pi, which is 3/4 pi. Boom. There we go. And so you've got the idea of how to convert degrees to radians. Now you're like, well, how far around the circle did I go? 30 degrees is roughly pi over 6 around the edge of a circle. Still a degree of rotation. How far rotated are we? But you're measuring from this point as opposed to from this point. Let's do a little bit of on the flip side. So if pi over 6, this is where we're going to convert to the other version, what we have written right here. X over 180 is equal to something over pi. Okay? So if I have pi over 6, and I know a full circle is 2 pi, what would be a half circle? Pi, right? So I know that's 360 degrees, that's 180 degrees. Well, I don't even have half of a circle. I have a sixth of a half of a circle. So I'm going to take that half circle, and if I divide it by 6, I'm going to take that 180 degrees and divide it by 6. So I am walking roughly 30 degrees if I take 180 and divide it by 6. So that is typically the way that I like to visually walk you through. If a full circle is 2 pi, 360, half is pi, which is 180. Well, I have pi over 6, which is going to be 180 over 6, which is 30 degrees. Let's say you don't like solving it that way. Let's solve number 11 algebraically. I know that I have some number of degrees over a full circle is equivalent to pi over 2 of a full circle. Both of these are full circles, and this is my fraction of a circle. So if I cross multiply, I get 360 pi over 2 is equal to 2 pi x. That's going to reduce down to 180. Pi is 2 pi x. Divide this by 2 pi, which is 180 pi divided by 2 pi. 180 divided by 2 is going to give me 90. Pi over pi cancels out. 90 degrees. Now, again, very straightforward, very algebraic, but I could have looked at it in terms of, well, what is a radian? Well, I know 2 pi is 360 degrees, which means pi is 180 degrees. Well, I have half of that. So half of 180 is going to be 90 degrees. I think conceptually this makes more sense. If you're more rigid and structured, doing the algebraic process is going to make more sense. So why don't you take a pause, try out number 13 or number 15, see how well you do. Unpause it when you're done. Whichever method you like, if you like algebraic or if you like conceptual, try that method and see if you get the same final answer. Okay, so let's take a look. So with this, I have pi over 2 radians. Again, we've already done this one, so cool shot. we're going to act like we haven't done this before. And instead of doing the 360, I'm going to do my shortened version, which is a lot of times what you'll see in other versions of texts. I know I have some degree measure over 180 degrees is equal to some radian measure, which is pi over 2 over pi degrees. I'm going to cross multiply it and say, okay, that's 180 pi over 2 is equal to pi x, or x pi. That's going to be 90 pi is pi x. Divide both sides by pi. That's going to be 90 equals x. Boom. 90 degrees. Over here, looks like we didn't do that problem already. We have 3 pi over 2. So I'm going to take this example right here. I'm going to say, okay, if a full circle, so full is 2 pi, that means half is pi. So if a full circle is 360 degrees, half is 180 degrees. Well, I'm taking that and I'm multiplying it times 3. So I'm going to take that 180 times 3, and then I'm dividing it in half. So 180 times 3 divided by 2. Let's see, that's going to be 90 times 3, which is 270 degrees. Let's see if I can get 270 degrees algebraically. So I have x over 360 is equal to 3 pi over 2 over 2 pi. Cross multiply. So that's 360 times 3 pi over 2 is equal to 2 pi x. 360 divided by 2 is 180 times 3 equals 2 pi x. If I divide that by 2 pi, let's see, that turns into 90 times 3. The pi's also cancel out, equals x, which is 270 degrees. So no matter which way you do it, you're going to end up with the same answer. And there you go.